Hello, everyone. Welcome to this week's Bounty episode of the podcast. I'm Spectre, with me is Z. In this episode, we have quite a few topics, including some stanza smuggling, HTTP3 connection contamination, a Sophos firewall issue, and more. First, though, thanks Nino Panda for the tier 1 sub. Really appreciate it. And yeah, let's jump into it. We'll head right into some exploits. Not really too much news today. With our first topic being a ZDI post on a Sophos firewall code injection. I'll pass this one over to you, Z.
And this one, I don't like to call out some of the poorly written posts, but I had a rough time reading this one. Just felt very verbose. And I think the code shows off the core of the issue pretty well. What you've got is, first of all, you've got kind of like a front end, it's like Jetty. Basically, it's running some Java code. It's coming in, hits a do filter, so this is set up as like a request check filter. And it just does some simple validation on your inputs. Not really a very complete validation though. Interesting here. Basically, for what's relevant for us at least, I guess not actually entirely relevant to this, but one thing it does, it'll iterate through basically all of the parameters, and all it does is check is valid request param key. It only actually validates the key, and all it's doing there. Sorry for those of you watching, seeing the Squarespace come up. All it really does there is check if it's ASCII, printable ASCII characters, but it's only checking the key and not the values. And it repeats that again when it gets this JSON object. You can just send JSON in as like a JSON parameter, and you send in the JSON object, parses that in, reads that, parses that, checks if all of the JSON keys are valid. But again, it's not checking any of the values. So this is just the front end, just doing some simple validation here before this gets passed on into a Perl script. Perl script is where it gets a little bit more fun. It ends up passing that JSON in to this block of code here, starting line 37. It's iterating over all of the keys in that JSON object, or they're calling it the hash object here, or hash map. Goes over them, looking for the discriminator key. What the discriminator is it's basically a key that it's a dictionary itself. It's a list of different key value mappings. So the discriminator, the fields underneath discriminator will have the name of a field that's part of the main JSON dictionary. So it's like mapping them there so it can create, I believe it's creating like a Perl object using the field names out of discriminator, but using the values out of like the actual JSON. And to do that, it kind of builds up this string here of kind of the dynamic names, where ob name to fetch ends up being the value of the field pointed to by the discriminator. It's kind of a little bit of indirection there. Either way, what ends up happening here is it's using eval. It's printing this string that the user controls into eval, and there's no validation going on. So it's got a really weird control flow as to how it's reaching here, but a pretty simple issue. And honestly, like the whole thing's a little bit weird. Just the whole control flow getting there, why they only validate the keys at the start, like that feels really weird to me. There's just a lot of questions going on here for such a simple vulnerability in a firewall. This code was taken from like the Sophos firewall. So another one of those cases of something that is, security tooling being very insecurely written. And I mean, using Perl in 2022. I'm sure this is old. Like, it's an old project, so I can maybe excuse it, but still, haven't seen Perl in a while.
Yeah, like you, when I read this, I had some questions, and I had to reread it a couple times actually, and reference the code a little bit. I would be like curious on some of the background here as to why this setup is the way it is, and like some of the usage there. Unfortunately, the post doesn't really go into the background on there. They do go pretty deep into certain aspects, although some of those aspects I think are kind of irrelevant and could have been cut out. But
Don't know why they had to include, like, here's what an HTTP request is, how it's defined in like the RFC.
yeah, there was stuff on like here's what JSON is and how it like what it like it's kind of silly, but like you said, the core issue boils down to just like untrusted input going to eval. But how that happens is a bit interesting. From a meta perspective, this vulnerability was interesting too because it was actually exploited in the wild. Towards the end of the post, near the conclusion, they mentioned there are reports that this vulnerability is being used to target a small group of organizations, and that Sophos has informed each of these affected organizations directly. It's also similar to a previous bug that was used by a Chinese APT group in March. So, yeah, I mean, it seems to be a pretty popular target for like targeted exploitation of various organizations, which makes sense. Like C said, it's security tooling, and it's the kind of thing that you would see in enterprise. But yeah, it's not too often we see like vulnerabilities that are confirmed to have been exploited in the wild like that, especially not from ZDI posts. So yeah, thought I'd call that out. But yeah, a bit of an interesting post in terms of how simple the bug was, but how complex the code flow was. And something that I would like to know a bit more on, but yeah, they just don't really go into it in this post.
Yeah, the code flow feels like the sort of thing that happens just as you kind of build on from legacy. So maybe really early on, they were using a bunch of these Perl scripts, and then they started trying to centralize, maybe doing some centralized security. And eventually they add on like the Jetty layer, and they add on this layer that's just validating all of the keys, kind of thing. Okay, we'll validate all the keys, but then applications are going to need different types of data, whatever. So they'll pass that along. And they have kind of the way of calling protocol. It feels very much to me like just adding layers and layers on top of legacy code. So that's what I would imagine kind of what's going on here is just more layers getting added and not really thinking about all the consequences, I guess, and decentralizing everything, but in a hard to follow way, I guess.
I think that's a fair assumption. It kind of makes sense with what we were saying with the code. So yeah, I'd be willing to believe it. All right. So up next, we have a vuln reported by Project Zero and Cisco Jabber, which is basically Cisco's chat application with messaging, voice, and video calling. This bug is in their use of XMPP for IM. For those who might not be familiar, XMPP is Extensible Messaging and Presence Protocol, fairly popular open source protocol that various IMs use. Zoom uses it as well. The last time we covered XMPP on the podcast was May 30th on episode 149, just before we went for our summer break. And that was also a stanza smuggling issue. And it actually gets linked to in this issue as well. So the main thing that's interesting with XMPP stanza smuggling is the fact that message stanzas from clients as well as control stanzas from the server are all in the same message stream. And clients have full control over the XML in a body tag. So the idea of stanza smuggling is to smuggle control stanzas to a client or to the server, which is done by taking advantage of parser differentials, for example. And in this case, the bug comes from Cisco's modification of the Glux library for parsing the incoming stream, particularly the close tag functionality. In the upstream Glux version, at the start of close tag, it would check if the tag was stream or if the prefix was stream. In that case, it would just return true. It was a very simple code block. Cisco's version, though, they add some code in there where they'll create a new tag and set it to the root. And the most relevant addition there is they do this call to cleanup, and they try to clean up the mdelete root. And that cleanup routine ends up resetting the parser state. So any XML tag after that point will be considered the root of the next stanza. So if an attacker simply sends a stream tag to cause the parser to reset, they can just smuggle the custom stanza in and get it processed. In the report, they give an example payload that could take advantage of this to add an arbitrary contact on behalf of the victim user and hijack their contact list. There are some other things that can be done as well, including taking it to code exec with enough work. The Zoom bug we covered on episode 149 actually did this, which they link to here as an example of what can be done. There, I think they took advantage of the stream error tag with a revoke token tag to create a cluster switch tag, and that would basically just allow them to MITM the communication between client and the server, which they would use to serve up a malicious update. There were some additional steps involved there because they had to do a downgrade attack first to not have a signature check on the cabinet file, but ultimately they were able to install a malicious update and get code execution on clients, which might be possible here. Like I said, they just kind of linked to it. I would imagine it would be possible in this case. I'm not really familiar with Cisco Jabber, so I am kind of speculating a little bit there. But given the fact that he links to it and calls it out, I'm guessing it's possible. But yeah, I mean, basically, it just comes down to bad like code being added by Cisco, not being aware of the cleanup call and its implications. Um, it,
I don't think it's necessarily that they weren't aware of its implications. I think it's more the thought of not thinking about injecting it into like the middle of a message, because it seems like that's an intentional modification. So like they were aware of exactly what it did, they just weren't thinking about malicious messages. Um, like
okay,
that stream tag could end anywhere, and that is kind of a weird, like it's a weird thing with. I mean, XML generally pretty freeform. You can do whatever you want, but you know, developers often think about everything being fairly well formed and like what they're actually sending to it, not necessarily about all the ways somebody could modify and like, you know, what happens if somebody sends this one specific tag somewhere we're not expecting it, you know, things break.
yeah, the way I was thinking about it was perhaps cleanup, like just that aspect of it where it would reset the parser state. I was thinking maybe they just weren't aware of that implication, but yeah, I mean, it is their custom edition, so maybe it is just the fact that they weren't expecting this stream tag to be like present there, and maybe they thought it was being filtered somewhere else or something like that. But yeah, I mean, it's kind of an interesting issue, and it's one of those areas that I feel like is good to look whenever you're looking at products like this, is looking at use of libraries and seeing if they've done any modifications. Just doing some dipping on dependencies like that and seeing if there was any strange code added is like, um, it's a bit of a code smell, I guess, and somewhere that's really good to look for bugs, and that's where Project Zero found bugs in this case. So just kind of highlighting that. But
Yeah, I mean,
yeah,
dipping a library is definitely kind of a red flag whenever you see it. I can't say I've seen it all that often. Where like, I mean, I say that, but there are a lot of cases where I can't see what libraries clients necessarily using server side things. Can't really see it. But yeah, I mean, it's good to look for that. I find this whole realm of XPP stanza smuggling to be pretty interesting because I think the first time we actually talked about it was during the Zoom
I
vuln
think
that
it
we
was
talked
too. I
about.
don't think we talked about it earlier than that.
Yeah, it's a really interesting exploit to kind of see and see it being exploit in this case, like now for a second time or you know multiple times. Um, Perhaps there's a longer history about it that I just don't know about. Um, it's an interesting vulnerability, I guess. I could imagine similar issues existing in other XMPP parsers. Granted, or not XML parsers. Granted, what's kind of unique with XMPP is the fact that it is this streaming or XML document rather than something that is just parsed once, like a text file or something. So it is a little bit different. Has a different context, I guess. But I don't know. It's an interesting bug. I'll leave it at that.
Yeah, I mean, it just kind of falls into like all these smuggling types of issues are pretty interesting in how they work. And like you said, because of the stream aspect, yeah, it's a bit unique in the way that the attacks work, and we haven't covered it too often. So it's cool to see it when it pops up again. Um, so recently, like you said, it's you know, I mean, it's been a couple months, but for our podcast, it's been like it's been like
Just a few
8 episodes.
episodes. Yeah.
Yeah.
Although
All right.
I'm guessing this was probably same guy from Project Zero reported both of
Yeah.
them.
Yeah. So probably just you know, we've seen this with Project Zero before, where they kind of get hooked on an attack surface and they just look for issues spanning across different products. You know, doing that kind of variance analysis. So
Yeah, I
this
mean
is another case of that.
when you spend so long getting up to date and like understanding a protocol, completely makes sense to start looking at everybody that implements a protocol. I
Yeah.
mean, it's actually even just a good way to go about bug hunting. You know, as you look into one, you see, oh, they fixed this bug in this way. You can look at another implementation and be like, oh, they didn't fix that bug. And you're kind of learning as you go between all of them.
Yeah. All right. So up next, we have an auth bypass, a file upload, and an arb file write exploit chain, and an undisclosed target. which all chained together for a $23,000 bounty. Getting into the individual bugs and the bug that kicked it off, the first one was kind of neat, though not super impactful on its own. Unfortunately, there is a lot of like background information that's lacking here, so we kind of just have to read the post and take it at its word because it's an undisclosed target. He wasn't allowed to disclose this by the vendor.
You mean he
So,
didn't actually find these issues on test.com?
I mean, maybe maybe that's just it's just a big ruse, and that's the yeah. But yeah, so the first bug was kind of neat, but not very impactful on its own. It seems this website had a dashboard that you would be able to access, and you'd get a JWT generated on login. And there was also an admin panel, which obviously isn't supposed to be accessible to public users. When they looked further at the token and decoded it, they noticed that it had this realm field in it, or parameter, and they kind of just played around with that and wanted to see what it would do. And they discovered it was used for authentication, used for like doing auth scoping. And they tried changing the realm to be the site name plus dashboard appended to the end of it. And that ended up working. They were able to log into the admin dashboard. Now, the company rated this low impact because it was kind of just the being able to access the client side rendering of the admin dashboard. It didn't really expose any of the sensitive endpoints yet. So there was like further bones needed, which I'll go into in this post. So it sounded like you wanted to say something though.
Yeah, I do want to jump in there. How we found that realm basically just came down to actually finding that dashboard, finding the app.js file, I believe it was. Double check there.
Yeah, I think he called out
found it in there.
And
that's where he was able to find like the list of realms, including the test dashboard one that he used. He didn't like brute force it or just guess it, but it was exposed kind of through the JavaScript of that it was using JWT and it was looking for this realm. And I thought it was really interesting that it was using that realm. I tend to mostly just see permissions being done through scope, and the API and everything for this application was just looking at the scope for it to have the appropriate scopes defined, not having the right realm. So I thought it was interesting that just that UI aspect ran using the realm, and odds are he would have been able to kind of fake this and get the same level of access without the JWT, because I'm assuming it just validated on the client side. Just check, is it signed and all of that, and that's. Although, in fairness, he did get a $3,000 bounty just for that aspect. And I think what's interesting there is actually how he got it generated, being that this login API endpoint just took realm as the parameter, which just feels like something you probably shouldn't be doing. Like, that shouldn't be something a user arbitrarily controls if you're going to be using realm in the first place. Or at least it should do further validation to make sure you're supposed to have access to that realm if you're going to use a realm. It feels like a needless feature if they're not even actually validating the realm when they create the tokens. So definitely a sign that something's going off, or something off. Something's a little bit off with this application. I'll let you keep going with the other issues though.
Yeah. So he was able to get the client-side rendering of the admin dashboard, but he tried using this upload endpoint, which was used for being able to upload files, but that didn't end up working because he didn't actually have the proper privileges to be able to access that, and there was also no other sensitive information there, so the impact was relatively low. So he started looking for some other issues. That's where the auth bypass comes into play, where they were playing with the headers and the requests to the admin panel. Particularly the auth header is where he focuses on here. So there they would send the bearer and the JWT token in there, and kind of thought like, okay, what if I just remove the bearer from the auth header? And that ended up working. They were able to remove the bearer, and yeah, they were able to get 200 responses from the privileged endpoints.
He did that with fuzzing. Strange. Not necessarily. He didn't necessarily think to try that. He fuzzed it, and it gave him that.
Yeah. But it's kind of an interesting bug because, like, I can't even really speculate as to what's going on there and why that works exactly.
Yeah, I've got no idea.
Yeah, that seems like way too easy. But
like, unless the only thing that even comes smart, well, I mean, some sort of fail open, doesn't get the right set up, but then you'd also maybe expect that to work with like a random string being sent in, which perhaps it
Yeah.
did. It's not explicit about that. But yeah, I mean, if it is the case where it's authorization just not using bear means it returns true, I guess another way I can maybe see it is you've got a fixed parser that is expecting, say, um, the validator to throw an exception if it doesn't match. And so it goes in there, it parses, it's like, hey, this it tries to parse out that first word. First word doesn't match anything it knows about and just returns rather than throwing an error. I can kind of imagine some sort of weird flow like that. Where like because it didn't match, it wasn't an invalid token, it just couldn't be validated and like not checking a return code. I could see something like that. But yeah, it's a really weird issue. But also interesting that did happen here. Maybe it'll happen elsewhere. Something to keep in mind. And I always like seeing fuzzing used on the web anyhow. I mean, yeah, it's used a lot for endpoint discovery, but seeing it used in a way like this to find a vulnerability is really cool.
Yeah, I agree. And that's an interesting way of speculating on why this could be the case, like an ignored return value just because it's hard to handle um and like deeper into the code. Yeah, like I could see that. But yeah, with that bypass, they were able to access the file upload endpoint, which they weren't able to access with the original bug, just changing the realm. From there, they found the file was being uploaded to an Amazon CloudFront instance. And beyond that, you had full control of the path, so you could just overwrite arbitrary files as well. Though that's not super surprising. This is supposed to be like an admin functionality, so it's mainly demonstrating one of the damaging things you can do with the exploit. I wouldn't really consider it a bug in and of itself, but yeah, it is something he took advantage of in this chain here. And it's pretty impactful, especially since the website assets like scripts and such are also hosted on that CloudFront instance. So an attacker can end up attacking users of the site with malicious scripts and whatnot. So yeah, I mean, an attacker can do a lot with that chain once they have it. But the main problem is just the fact they can, get to those authenticated endpoints in the first place. Um, but yeah, I
Yeah,
mean,
I mean,
pretty impactful chain, and that's why it netted a $23,000 bounty. But yeah, some strange like things in this target that was looked at. Unfortunately, it's really hard to speculate where we don't even know what the target was. But uh, yeah, some of these things I wouldn't have really expected to work, but they did.
yeah, so that auth bypass is. I mean, the realm thing, okay, I can imagine it. It did just happen to be UI only, so you actually got a really good bounty for that, like $3,000 just for what effectively, at least the way it's described here. I imagine he could have done the same, just tampering with JavaScript to like ignore the JWT check in app.js. So $3,000 as a bounty on that, it's a pretty solid bounty. Um, he does call out that being able to overwrite arbitrary files in S3 has a misconfiguration, and I don't know if I entirely agree with him there. That feels a little bit more just like a feature. You might want to harden it, but not necessarily a misconfiguration when you don't want, because sometimes you need to overwrite files. It's a file store. Some files update. It really depends on your usage as to whether or not you're going to need to overwrite or not. If say every deployment goes into its own little subfolder with a hash name or something, okay, maybe you don't need to overwrite anything, but I don't know. I mean, he calls that out as like this default vulnerability in S3, and I don't entirely agree there, but I don't know if you have any opinion on that.
Yeah, I mean, like I said, I think this is just something where it's intended functionality because it's meant to be locked, like only accessible to admins. So he kind of tries to call this out as like a bug in and of itself, and I don't like really agree with that. Um, I
So
think that
the admin feature is, should admins have a web UI for overwriting anything in there? I mean, that's going to depend on what this looks like, but that's going to depend so much on context, I think, as in terms of being an admin feature that can overwrite files. I could definitely
yeah,
argue for hardening where you don't give admins the ability to overwrite any file, but rather, keep it restrained or constrained to just the folder, um, some particular types of files, not the assets for the actual page, because those I'd imagine should be deployed ideally through CI or something, not through upload your new JavaScript or HTML files. So like there is an argument to be made for hardening there. I
Yeah,
was
you
more
you
thinking
can.
about the S3 as like the default.
Yeah, you can totally make an argument for like a defense in depth kind of thing here, but in and of itself, yeah, I wouldn't consider it a bug. So yeah, um, yeah, a bit of an interesting like chain there, but yeah, like I
Yeah,
said,
cool
it's kind
find.
of shocking issues. Yeah, for sure. All right, so up next we have a post by Security Intelligence on an analysis of an RCE in Cobalt Strike, which is a pen testing tool which features a command and control or C2 framework. So kind of a fun target to hit as it's a red team tool in and of itself. Haven't really seen, you know, vulnerabilities or exploits targeting these in a while on the show. Not only are they fun targets because of the idea of attacking attacker tools, but also because they have kind of a unique attack scenario for things like counterintelligence and can be very interesting for higher level threat actors. Z, I'll let you take this one away.
Yeah, and they kind of figured out what this bug was through patch analysis. The core bug, I think, is actually really neat. And like you said, you've got just the aspect of this is in Cobalt Strike. It is somewhat I mean, it is one of the more popular available C2 frameworks, so it's used, it's out there. Yeah, having an opportunity if you've been on the blue side, having an opportunity to mess with the red team can always be fun. So yeah, this is one of those issues that could have been used there. What it comes down to though is Swing UI. So Java, I believe it is part of the SDK. Swing's kind of like the default or um the UI toolkit that actually comes with standard Java SDK. And what it does is when it gets a string that starts with just the kind of angle bracket, so like the HTML start tag, XML, the angle bracket for that. If it gets that, it tries to parse whatever the content is as as HTML. Sorry. It'll parse it as HTML. So you end off like, as a useful thing, maybe you want to have a label where you actually put like different size text in there. Kind of makes sense, but it's also feeling like a pretty dangerous functionality to, just support HTML, especially as you dig into it. What they found is that there was the HTML object tag that you could include an object tag, which then included I believe it was class ID. Yeah, you can include the class ID parameter into that tag, and what it would do is it would try and load whatever that class name you gave it. It would try and create that class. It would check if it was a component object, so it would look for it to be like of the right type. If it wasn't, it would go into the error case. But still, it would try and load a Java class, and not only that, any of the parameters, it would call all of the setters for any params that you provide in there as part of the HTML. So what they found is they can invoke or create a JSVG canvas, so an SVG canvas, and inside there they've got script execution. They can go ahead and provide a script tag and have arbitrary JavaScript running in there if they wanted to. But even worse than that is that the script tag supported this xlink href attribute where you could provide the href and provided a jar file. So code execution by being able, where the start point is you need to be able to have a string going into one of these Swing UI elements, start with an angle bracket. That's the only requirement. And as you can imagine, a C2 framework, it's going to be trying to display a lot of data that comes from the compromised host or where you're running, where you've got the implant on. So
The definition of untrusted, basically.
yeah. So what they talk about is like you could say modify the memory of the beacon itself, or you could have like a process running on your system that looks like HTML that it'll parse. Just that's the process name. You can do things like that. So there's a lot of ways you can get access to just executing code. And the fact that it supports just straight up like running a jar from basically nothing, like, yeah, my label definitely needs to run a jar file. just kind of a crazy path, the way it kind of reached through and got into everything there. Uh, Great bug. I mean, it's always fun to see these bugs in the security tools because you think of security tools as hopefully being secure, but time and time again, you tend to see that, maybe security professionals aren't the best at writing secure code, or maybe nobody's good at that. I don't know, but
I think
I don't know,
that's the right
definitely,
answer. Nobody's good at it.
yeah, definitely a fun bug though. I really like this post. It's just fun to see those issues pop up here.
And something I'd like to call out too is not only is it kind of a funny flow and how easy it is to exploit and the fact you can get code execution so easily off of it, it's also one of those things where it's going to be like 100% reliable. You're getting code execution through you're not using memory corruption or anything with this. This is like a higher level issue where you're going to be able to get reliable exploitation of it. And I want to call that out specifically because in this blog post, they mentioned the counterintelligence aspect and stuff like that. When you're doing counterintelligence, like not alerting the other side that you're doing it is a pretty important aspect of that. So an exploit like this, where you have like 100% reliability and it's so easy and so effective, um, that's like a gold mine for that kind of scenario. So yeah, that makes it an extremely cool exploit chain as well.
Yeah,
But yeah,
although I don't know. I know it's used a lot on like the red team, so being able to compromise somebody who's doing a red team engagement is one thing. I can't imagine a lot of like nation state actors are really running with Cobalt Strike. Um,
you never know, to be
Never
honest.
know. My imagination tells me otherwise, but I don't actually know. I'm not involved in that way. I don't have insight to it. So who knows?
You
Maybe
know
they are
what?
all running Cobalt Strike. But that is kind of the one place where I'd say it is a little bit mediated, but still attacking red teamers. You can still find out about plenty of vulnerabilities that way. Oftentimes they're going to be aware of at least some vulnerabilities, either from engagements they've worked on or access to. It's a place to pivot. Like it is a high value target.
I wish I could point exactly to like evidence or whatever, but I feel like a long time ago, back when we had Anti on the show, we had talked about a nation state actor using Cobalt Strike. I feel like it was detailed in a in one of the threat intel posts that we covered at the time. But
Perhaps
unfortunately,
I
it was so long ago that like it's ringing a bell in my head, but I can't like point to it. So yeah, I
Perhaps,
mean,
yeah, we haven't had him on in a long time, so that would have been a
yeah,
pretty old episode. I mean,
yeah,
it's
my memory
possible.
might be
It's
failing me there, but yeah, I feel like there has been cases of nation states using Cobalt Strike documented in the past. So
yeah. I
um,
mean, I don't have any proof that it's definitely possible. In all honesty, it is a possibility. My imagination likes to assume, they're going to be, you know, doing all the cool hacker things, but in reality, oftentimes go with what works. Let somebody else
go with what's
maintain it for
easier.
you. Yeah.
Yeah, yeah, exactly. Path of least resistance. That's the favorite path. All right. So we'll get into our last topic here, which is a research post on HTTP3 by Portswigger. And it talks about connection coalescing and how it can be dangerous, especially when paired with first request routing, which I think we mentioned before.
We've covered
We've
it
covered a lot of
once.
yeah, I thought so. We've covered Portswigger quite a bit, so I figure we would have covered that. But anyway, yeah, it's a bit of a shorter research post, just kind of bringing awareness to it. Z, I'll let you take this one.
Yeah, so as I mentioned, we covered this once before, and that was when talking about browser power desyncs. I think it was our first web app episode back, or back from the break, because that came out during the summer. Where in his post there he talks about this first request routing, which is basically if you're familiar with like HTTP pipelining or just any time where you can kind of end up having multiple requests sent one after the other without actually closing the request in between, the assumption, or by some servers, not all servers, the vulnerable assumption that can be made is that the first host in the very first request sent is going to be the host used for all of them. So it'll, see, okay, we're going to host a.com and it'll open the target there and just forward everything you sent through and not keep validating the host to make sure it's actually supposed to go to a.com. And so what's going on here is with HTTP 2, they introduced connection coalescing, which lets them reuse the single HTTP 2 request for going to different websites. As long as they resolve to the same IP and the certificate used for them is valid on both of the host names. So what they call it here is like a potential problem then is, so let's say you have your setup where you have their example is star.example.com, so wildcard example.com, certificate valid for any of those subdomains. And you might have, say, admin in WordPress. So you have XSS on WordPress. Suddenly you can take advantage of this coalescing to send a request over to admin, and kind of do these cross-domain attacks because of things getting coalesced. If you also, combined with that first request routing. So if a connection gets coalesced plus it does the first request routing, this would be a way to actually kind of take advantage of that. It is mostly theoretical attack at this point. I don't think he calls out any like actual instances of it. Just like it's something to be aware of now that it's also introducing this ability to coalesce requests to different domains on that as a way of attacking other domains. Which is a cool attack, but does rely on having that one fundamental vulnerability in the front end proxy. But still kind of neat to see an attack that does cross that barrier, going across different websites. So as the example they give, an XSS on WordPress, make a request so coalesces with the secure domain, and have your XSS actually start accessing and be able to inject scripts on running within the secure domain or admin domain context. Full attack thought, but yeah, mostly theoretical at this point.
Still, I think something good to be aware of, and as is the case with some of the other Portswigger posts, something that might become a lot more of an issue and more prevalent in the future, even though it might not be at the moment. Especially with HTTP, it seems like they are gung-ho on putting in all these like shiny, interesting features that like nobody realistically cares about, and
The
because of
browser
that,
devs care.
yeah, sure, the browser
and
keeps them in work, I guess.
I guess I should also mention this is HTTP 3 connection contamination. The key thing there is HTTP 2 requires the IPs to be the same. HTTP 3 removes that requirement.
Yeah. So, like I said, it seems like the HTTP Standards Committee or whatever is gung ho on pushing these like new features that are really dangerous and easy to misuse, and nobody really cares about them. So at the moment, they're not really like too impactful because most servers don't even really support it. But if they do eventually support it, which maybe we will one day see, we'll see like entire new classes of attacks, like attack classes, spring up. So, yeah.
Yeah, I
Like
can
we
imagine.
always say this with Portswigger, but they put out a lot of research that's very forward looking. So something to bookmark and come back to.
Yeah, like this one does kind of depend. I mean, technically you can do it with HTTP 2 if you have that wildcard cert and going to the same address. But ultimately it still does depend on that first request routing issue, which is, less common to see. It's not necessarily HTTP that's the problem. HTTP is just trying to save on the connection time, or like needing to establish a brand new connection, going through the whole handshake and stuff. It adds up. They're just trying to make things faster. It's not necessarily that it's getting misused. Just if you're not considering all of the cases that HTTP supports, and they are, feels like they're moving kind of quickly now. But I mean, HTTP 3 is. I think this is just a proposal at this point. It's not actually an accepted RFC.
Yeah, they do say HTTP 3 proposes removing the requirement, so it sounds like it's not something that's finalized. But yeah, I mean, but along those lines of like HTTP features and just disabling them outright, James Kettle actually calls out like to avoid these risks before they become a reality, ensure your reverse proxies just don't perform burst request routing. So yeah, I mean, just disable them basically, disable the features. So yeah, like I said, more of a forward-looking post. It's
Well,
somewhat theoretical right now, but still worth being aware of.
I will kind of correct that. First request routing is a vulnerability whenever it happens. It's not disabling a feature. It's not implementing a vulnerability. Like there's no situation where that's the correct thing to
Oh,
do.
sorry. Yeah, true. Fair enough. Yeah, I kind of got things mixed up there.
Yeah, fair. I kind of know what you meant, but want to clarify for our listeners.
Yeah. All right. But yeah, that's pretty much all the posts that we have for today. So as always, thank you everyone who tuned in. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcast, more links on Anchor. If you want to join the Discord and follow us on Twitter, links for those are down below or in the chat. As usual, we'll be back tomorrow for the binary episode. That's at 4 p.m. or 7 p.m. Eastern, 4 p.m. Pacific, and we'll see you then.